This question is based on the correlation between bond order and bond length. Bond order, we have seen about this. Bond order is the number of covalent bonds present in a system, whereas bond length is the distance between the participating atoms in the covalent linkage. That is called bond length. So the difference between bond order and bond length and their correlation is in this question. This question reads as which of the following species? So they have given the bond order. So bond order, question bond order in NO, nitric oxide, NO plus nitrosyl cation, they are given. Bond order in nitric oxide is given as 2.5 and bond order in nitrosyl cation is given as 3, that is 3.0. The question is, which of the following statements is true about these two species? That is, first choice reads as bond length of NO plus, bond length of NO plus is equal to bond length of nitric oxide, neutral species. Second, this is one choice. Second choice reads as bond length of nitric oxide, bond length of nitric oxide is greater than that of nitrosyl cation, nitrosyl cation. Third choice reads as bond length of nitrosyl cation, nitrosyl cation is greater than that of nitric oxide. Fourth choice, none of the statements is true, it is given. So the question is, so these are the data about the question. Bond order in the molecule nitric oxide is given as 2.5. Bond order in the nitrosyl cation, NO plus is nitrosyl cation. Nitrosyl cation is given as 3. Which of the following statements? They have given for some identities or inequalities given, or even none, it is given. So which of the following statements is true about these two species? They have compared merely the bond lengths of the two species. Bond length will it be less than or greater than or equal to, or nothing can be told about the bond length and bond order. That is the question. Here we have to note that, remember that bond length is inversely related to bond order. Already we have studied that bond order is the number of bonds. C single bond, C double bond, C triple bond. The distance between the carbon atoms in these cases is called bond length. Whereas bond order is 1, 2, 3. Whereas bond length goes on decreasing. Multiple bonded systems means the atoms are brought closer because the same two atoms are connected by 2 covalent bonds. Same two atoms are connected by 3 covalent bonds. Here the same 2 atoms are connected only by 1 covalent bond. If the bond means which binds together. 2 atoms are connected by means of only 1 linkage, bond length is reasonable. If they are connected by 2 linkages, the atoms will be closer. 3 linkages still more closer. So bond length is inversely related. So number of double bonds is nothing but bond order. So C triple bond means bond order is 3. C single bond means bond order is 1. C double bond order is 2. So in general, bond length is inversely related to bond order. So let us compare this NO. So bond order of NO is less than that of NO plus. It is given as per the statement. That can be put in the mathematical form. So 2.5 is less than 3. The given data can be represented in this manner. That is, bond order of nitric oxide is less than that of nitrosyl cation. But we know the correlation or variation between them. Bond length varies inversely with the bond order. Means that if it is less than, the bond length would be higher. Bond length of nitrosyl and nitric oxide will be in this order, in this manner. So bond length NO plus. This will be the correct choice. So this choice reads where BlNO greater than BlNO plus. So second choice is the correct choice for this statement. In general, we got to remember that what is the relation or correlation between bond length and bond order. Bond order varies inversely with the bond length. Higher the bond order means lower is the bond length. Bond order values are given. It means that inverse variation with respect to bond length. Accordingly, definitely they cannot be equal. And none is true is not also correct. One of them is correct. So the correct choice is second choice, which states that bond length of nitric oxide is higher than that of nitrosyl cation. So this finishes the analysis of this question. Here we got to remember the variation between the bond length and bond order, that is to be noted. Now this question is based on nature of bonding, nature of hydrogen bonding. We have studied about the 5 types of chemical bonding: covalent bonding, electrovalent bonding, coordinate bonding, hydrogen bonding, metallic bonding. In the case of hydrogen bonding, we have studied 2 types: intramolecular hydrogen bonding, intermolecular hydrogen bonding. Intramolecular hydrogen bonding means hydrogen bonding existing between the, so first let us define what is meant by hydrogen bonding. Hydrogen bonding is the phenomenon of interaction between hydrogen and more electronegative atom. So this bonding, if it exists within the molecule, it is called intramolecular hydrogen bonding. This bonding, if it exists between the molecules, it is called the intermolecular hydrogen bonding. Now the question is that which of the following species contains intramolecular hydrogen bonding? Question. We have given 4 choices. Which of the following species contains intramolecular hydrogen bonding? 4 compounds are given: hydrogen peroxide H2O2, hydrogen cyanide. 4 choices are: first choice is hydrogen peroxide, second choice hydrogen cyanide, hydrogen, carbon and nitrogen. Third choice is cellulose. So they will give in any manner. Some species will be given as formula, some species will be given as words. So actual formula for cellulose is C6H10O5 N times, but here it is given only as cellulose. Fourth one, concentrated acetic acid. Concentrated acetic acid formula CH3COOH. So which of the following species, the question is read once again, which of the following species contains intramolecular hydrogen bonding? Definitely hydrogen bonding would be there, because hydrogen is there, more electronegative atom, oxygen, nitrogen, carbon are there. Definitely hydrogen bonding would be there, but hydrogen bonding, whether it exists within the molecule or between the molecules, we have to identify the species where it is within the molecule. One by one analysis. We will study about this hydrogen peroxide in later stage, that is hydrogen compounds. This is the structure of hydrogen peroxide. H2O2. 2 oxygen atoms, each show hydrogen valency shows 1, hydrogen valency shows 1, oxygen shows 2 valency everywhere. So this will be. So if at all hydrogen bonding will be there, it will be between 2 other molecules. Between 2 molecules, or it is intermolecular hydrogen bonding. Similarly, hydrogen cyanide is a linear molecule, HCN. So here there is no choice. So of these 2, nitrogen is more electronegative, but nitrogen cannot attract hydrogen. This is meant by directional nature. We have studied about ionic bonding is non-directional, covalent bonding is directional. Directional means hydrogen is far apart from the nitrogen. Even though nitrogen is more electronegative, it cannot hydrogen from the farthest position, hydrogen's electron from the farthest position. If there is some other atom in this manner, so there can be hydrogen bonding between the 2 molecules. Here also it is intermolecular hydrogen bonding. Similarly is the case with acetic acid. Acetic acid CH3COOH, CH3 COH. CH3 CO double on OH. This is the structure for acetic acid. CH3 COOH. This hydrogen will be in hydroxyl hydrogen only will be involved in bonding. COCH3 in this fashion. So once again here also this actually it will be between oxygen and hydrogen. Oxygen and hydrogen. Here also intermolecular hydrogen bonding between two molecules. Everywhere it is between two molecules. Now coming to the structure of cellulose. Cellulose is made up of linkages called glycosidic linkages. Cellulose structure is written in the form of ring structure in this fashion. Actual cellulose ring structure, it is made up of glucose units. Cellulose formula is C6H10O5 n times. That is, it is made up of number of glucose units. So the glucose units are held together by means of what is called glycosidic linkage. In the glucose units, they are in the form of ring structure. Out of 5 oxygen atom, 1 oxygen atom is in the ring. Other oxygen atoms can be in the side chain. That is to be noted. This represents 1 glucose unit. Glucose unit means 6 carbon atoms. 1, 2, 3, 4, 5, 6 carbon atoms. C6. Next glucose unit is in this form. There are different conformations for glucose unit, chair, boat, etc. Here it is mentioned. So this is OH. C6H10O5. So this is one. It is actually covalent linkage. It has to be written in this form. It is OH. So hydrogen atom of 1 glucose unit is connected to oxygen atom of other glucose unit. Of course, it is extending in this fashion OH. So it goes on like this. So there will be line like this. This line does not represent free methyl group. It represents the adjacent units. Dotted versions represent the adjacent units. Smallest unit of a cellulose. So any cellulose is made up of 2 glucose units. Small 2 glucose units. Cellulose is a high polymer. Between the glucose units there is a hydrogen bonding, but cellulose is made up of glucose units. So hydrogen bonding exists within the molecule, but hydrogen bonding exists between glucose units. Glucose is only unit, it is not a molecule. So hydrogen bonding in this case is present within the molecule, or it is called intramolecular hydrogen bonding. So intramolecular hydrogen bonding is present preferably in cellulose. All other species, as we discussed, contain intermolecular hydrogen bonding. That is, hydrogen bonding exists between the 2 molecules of H2O2 or HCl or acetic acid, as the case may be. Even though concentrated acetic acid between acetic acid molecules. Why it is mentioned concentrated acetic acid? If it is mentioned as dilute acetic acid, there will be hydrogen bonding between acetic acid and water molecules. Acetic acid and water molecules. That is why it is mentioned as concentrated acetic acid. So this finishes the analysis of this question. Now next question is based on the hybridization and structure, chemical bonding and structure of molecule. So this hybridization, the question is, what is the hybridization of atomic orbitals of nitrogen in the following species? They have given 3 species. NO2 plus, that is nitrite cation, nitrate group. So NO2, in the case of NO and NO2 we have to be careful. NO is a neutral molecule, nitric oxide in inorganic chemistry, whereas NO plus is a nitrosyl cation acting as electrophile in organic chemistry. Here also NO2 is nitrogen dioxide, is a neutral molecule in inorganic chemistry. Nitrogen dioxide cation is the electrophile in organic chemistry. That is to be noted. All are species of nitrogen. NO2 plus is one species. NO3 minus, that is nitrate. Nitric acid is HNO3, H plus NO3 minus. nitrate is NO3 minus, ammonium ion NH4 plus. They have given 3 species. They have asked about the atomic orbital of nitrogen in all these species. Its hybridization. What is the hybridization of atomic orbital of nitrogen in this they have given. So hybridization they have given sp, sp2, sp3 hybridization. Hybridization important types of hybridization are sp, sp2, sp3, sp3d and sp3d2, that is to be. In these cases already we have seen that if the system contains only single bond, it is made up of sp3 hybridization. If it contains one double bond, it contains sp2 hybridization. If it contains two double bonds, it contains sp hybridization, like that. So sp hybridization may be linear, sp2. Now we will see the structure. All these are examples of nitrogen containing cationic or anionic species, but the structure has to be carefully noted. Now let us write the structure. This is the structure for NO2 plus. NO2 plus. NO2 plus. This is the structure. Here it contains two double bonds. So you have to remember this. Only single bonds means sp3 hybridization. One double bond or one pi bond means sp2 hybridization. Two bi-bonds or triple bond, it is sp hybridization. This we have seen. Alkanes, alkenes, alkynes. We have seen alkanes CnH2n plus 2. We have already discussed about these structures. C2H6, C2H4 and C2H2. C2H6 is ethane. Its structure is fully only single bond. CH3, CH3 in this fashion. Whereas C2H4 is double bonded system. 4 hydrogen atoms are single bonded but carbon-carbon double bond. Whereas C2H2 is acetylene. Its structure is C triple bond C, and so CH linkages are always single bond. CC linkage can be single bond or double bond or triple bond. So if it is single bond only sigma bonds, this contains only sigma bonds. Ethane contains only sigma bonds. Means that here carbon-carbon hybridization is sp3. If it contains one double bond, that is here only one double bond or pi bond, it is an example of sp2 hybridization. Here it contains one sigma bond and two pi bonds. So two pi bonds means it is sp hybridization. This we have already seen. Just to recall, if the system contains only sigma bonds or single bonds, it is sp3 hybridized. If the system contains it is only one pi bond. If the system contains only one pi bond, the carbon-carbon hybridization is sp2. Whereas if it contains two pi bonds, sp hybridization. Here we have illustrated with the example of carbon. We have studied with respect to carbon. Here it is given nitrogen. So we don't bother about, we need not bother about the elements. We have to analyze for the presence of single bond or double. Here also two double bonds are there. So two double bonds means sp hybridization. Two double bonds means it already we have seen. It contains two double bonds sp hybridization. Here also nitrogen two double bond. Here it is one double bond. Here it is one pi bond. Our number of pi bonds is 2. So it is sp hybridization. Now coming to the structure of nitrate anion, NIT, or here we have to be careful about the spelling. NITRATE. Nitrate means its formula is NO3 minus. Nitrite means NO2 minus. That is different. Here it is given as nitrate. Nitrate structure will be in this form. Right? One double bond, one coordinate bond, and one oxygen anion linkage, covalent bond. So here if we analyze, all this is single bond. Single bond means only sigma bond. Here two bonds, one of them sigma, one pi bond. So this nitrate anion contains one pi bond. Already we have seen that NO2 plus nitrosyl cation contains two pi bonds. Two pi bonds means Acetylene also contains 2 pi bonds. It may contain triple bonded system, but number of pi bonds is only 2. So 2 pi bonds. 2 pi bonds means hybridization is sp. So sp hybridization for nitrosyl cation, whereas only 1 pi bond. 1 pi bond means sp2 hybridization. So nitrate anion, its hybridization is sp2. Quite, it is easy to remember. That is ammonium ion, just 4H plus, but plus it is containing. Everywhere it is single bond only. It is only single bond. So it is only single bond means it is sp3 hybridization. So the correct hybridization is nitrosyl cation, nitrate. It is not nitrosyl. NO plus means nitrosyl. NO2 plus means nitrite or NO2 cation. NO2 cation hybridization is sp hybridization. NO3 minus, nitrate anion, its hybridization is sp2. Ammonium ion, its hybridization is sp3. So the correct orders of hybridization sp, sp2 and sp3. So this is the correct order of hybridization. In the choices they will mix up. These choices would be 4 different choices will be arising. You go 3 sets. It can be mixed in any manner. First one sp2, sp3, sp. In a haphazard manner it will be given. You have to choose that order where NO2 plus species is sp hybridized, nitrate is sp2 hybridized, whereas ammonium ion is sp3 hybridization. So this is the order of hybridization for these species. In this we have to remember all are only nitrogen, all are nitrogen containing species. We have to analyze for the presence or absence or number of pi bonds, that is to be noted.